These three things have something in common. A student choosing a university, a cafe owner choosing ad spend, a banker choosing interest rates. Three very different worlds, one shared problem. They all need regression analysis to make the right call. Today we use Excel to show you exactly how regression works. Example 1. Does education increase income? More education should mean higher income. Simple, right? But income depends on many things at once, such as education, experience, industry, location, skills, motivation, etc. A simple average cannot separate these out. Look at this. A graduate in finance, major city, high salary. A non-graduate, rural area, low salary. Education or location and industry, we cannot tell. Regression separates the effects. Income is Y, education, experience, location, industry are X. Each effect is isolated.
The result? 1 extra year of education raises income by 8 to 10%, holding everything else constant. This number shaped policy across dozens of countries. Without regression, we would just be guessing.
In example 2, we address the question, does advertising increase sales? Meet Sarah. She owns a cafe. Every month, she spends on Instagram, flyers, and influencer posts. Which channel is working? Which is wasting her money? Let's open Excel and find out. 15 months of data, sales in thousands, that's Y. Advertising in Instagram, flyers, influencer, that's X1, X2, X3. In month 1, Sarah's sales is 45 and cost of advertising in Instagram 2, flyers 1, influencer 0. Month 2, sales 52 and cost of advertising in Instagram is 3, flyers 1, influencer 1. 15 similar rows. 3 clicks, data tab, data analysis, regression, okay. Missing data analysis? In such case, go to File, More, Options, Add-ins, Analysis Toolpack, Go, Tick, OK. Done. Tell Excel what to compare. Y range, sales column. What we are explaining. X range, Instagram, flyers, influencer together. Tick labels. New worksheet. OK. 15 months of data, sales in thousands, that's Y. Advertising in Instagram, flyers, influencer, that's X1, X2, X3. In month 1, Sarah's sales is 45 and cost of advertising in Instagram 2, flyers 1, influencer 0. Month 2, sales 52 and cost of advertising in Instagram is 3, flyers 1, influencer 1. 15 similar rows. Instagram, coefficient 5.2, p-value 0.001. Every extra $1,000 spent as advertisement on Instagram, sales up by $5,200 on average. In other words, for every dollar spent on Instagram, Sarah gets $5.20 back, holding others constant. Well under 0.05, real, not random. The high return justifies putting more money into Instagram. Flyers, coefficient 1.8, p-value 0.03. Every extra $1,000 spent on flyers, sales up by $1,800 on average, holding others constant. Positive, but smaller than Instagram, still significant, just weaker. Verdict, it is justified for Sarah to keep it without expanding. Influencer, coefficient 0.4, p-value 0.42. Barely any return, p equals 0.42, far above 0.05. Random noise. Verdict, cut. Stop wasting money. R squared equals 0.85. Our three X's explain 85% of sales. Strong fit. Weather, competitors, and holidays account for the rest. Look at this. 3 boxes, 3 numbers, 3 calls. Instagram, $5.20 back per dollar spent, increase. Flyers, $1.80 back per dollar spent, keep. Influencer, 40 cent back per dollar spent, cut. Not a guess, a number for every channel, a decision for every number. 15 rows, a few clicks, one clear answer. So far, regression for a cafe owner, but the same tool guides decisions that affect millions. Does interest rate affect inflation? When your central bank raises rates, your grocery bill, rent, and loan payments all change. But how much? How long? Central banks use regression to find out. But inflation also feeds on oil prices, exchange rates, supply chains, and consumer confidence. Regression separates the rate effect from all of that. Result? A 0.25% hike leads to roughly 0.3% lower inflation over 12 months. Not intuition, a precise number guiding policy for millions. What all three share: 1. A clear question. Does X affect Y? 2. Confounding variables. Simple observation is never enough. 3. A specific number, not just yes, exactly how large and in which direction. Getting that number is not a mystery. You just watched it happen. What regression cannot do, cannot prove causation, only associated with, cannot find what was never measured, can be misused, leave out variables, get the answer you want. Good economists are transparent and honest about uncertainty. Recap: 8 to 10% income gain per extra year of education, $5.20. Best return in Sarah's marketing spend, minus 0.3%. Inflation drop from a 0.25% rate hike. Regression isolates one effect, controls for everything else, gives you a number you can act on. Now your turn. Pause and answer this. Sarah's friend runs a bakery. Same regression, this result. Facebook ads, coefficient 3.5, p-value 0.001, email newsletter, coefficient 0.9, p-value 0.08, TikTok ads, coefficient 2.1, p-value 0.04. Which channel should she increase, keep, and cut? Facebook ads 3.5, p-value 0.001, significant, best return, keep it running. TikTok ads 2.1, p-value 0.04, significant, strong return, increase here. Email newsletter 0.9, p-value 0.08, not significant, cut or reduce. Remember, not significant does not mean zero effect. It means not enough proof. If you got all three right, well done. If this helped, like and subscribe. New lessons every week. Simple, clear, to the point. See you in the next one.